by what we call the square root principle. In other words, we can either factor it or we can solve it by the square root principle. So taking the square root of both sides, x is equal to plus or minus the square root of 4, where x is equal to plus or minus 2. So then here's our solutions. -2, -5/4, and 2. Okay? Any questions? So one of the things that's important to remember, your highest power there, that 3, that gives you an indication of how many solutions you may have. You'll never have more than that. You'll have at least 3 solutions. 2, and you could have some that repeat, but that's how many solutions you should have. All right, let's see what's next. All right, so solving a radical equation. That's simply a matter of just putting the radicals, isolating the radicals. You don't want 2 radicals on one side, that I can assure you of. So what we're going to do is we're going to subtract that for a second one, which means it's going to be a negative 2 minus x. And then what we're going to do is we got to square both sides. And that's going to get rid of one of the radicals. And then we'll have to collect like terms and do it again. In 097, if you had that, you work a little bit with radical equations, but the problem being there, you didn't have any quite like this where you have to do them twice. Now, all I'm doing is just squaring this whole thing out, just like it was any kind of binomial. The only thing that's different is it's going to have one of these in there. So you can FOIL it out if you want to, but I'm saving time by using the, what we call in the 097 one of the special products. It's this squared, it's this one squared, and in the middle you got 4 times this times 2, which gives you 8. And then squaring that just takes it out of there. And you see now you only got 1 radical. So now we got to put together our like terms. So 16 and 2 is 18. And then I'm going to put the negative x over here. And then these are going to go on the other side. And then what we get to do when we get isolated, we're going to square again. On. Now, what we could do here if we wanted to, I'm not going to do it just because it might take a little bit more time. It might save time in the long run, but you'll notice there's a common factor, a 2 on all three of those. So you could factor out a 2 if you wanted to divide, in other words, divide each term by 2. But all I'm going to do is I'm going to square both sides, and that's going to get rid of that radical. Because we can't really solve this until we get rid of the radical that has the x in it. So again, using the same thing that I did up here, where was it? Here. I'm going to do that here. Two times 12 is 24 times 2, so that's negative 48x. And then that's 144 when you square 12. And the good stuff part about this is going to be positive, so that's going to be a 64, 8, and then this is going to come out of there, 2 minus x. So now we're just going to simplify as far as we can. So this is 128 with the same thing over here. So I'm going to have to go up on the other side. So then that's minus 128. Both sides, we're going to get it into a square, 64x. So that way it's going to be set to 0. All right, so those are different signs. So now, moving up here, we got 4x squared, and then the 144 minus 128 is just going to be 16. And then we got 48 minus 64. So that's positive 16 as well, with 16x. And as I said, you see, you can still see there's a common factor of 4 there. So you could easily do that to solve this. So if we had done that before, we wouldn't have to do it now. So what's the solution to that one? That one is a perfect square. That's x plus 2, 0, not x. So then x would be equal to negative 2. All that to find out negative 2. All right. Now, here's the thing is, does that give us a true statement in the original one? This is what we have to check. All right, so I'm just going to briefly check it over here without working it out by hand because it'll just take forever. But if we put negative 2 in here, we're going to have square root of 4. And then if we put it in the other one, we've got 2 minus a minus 2, which is also going to be the square root of 4. Square root of 4 is 2, plus square root of 4 is 2, and that's equal to oh, good, it scared me. So that's it. It's a negative 2 is the only one. All right. Hopefully this is a short one, and I know it is. How do you tell when something's a function? They're asking when it's not representing a function. So we do the horizontal line test, and you can use the y-axis to do that for you. And imagine it just moving back and forth across. So if we intersect in more than 2 spots vertically, then we don't have a function. So this is a function, this is a function, this is a function, this is not a function. Questions about that? All right, so the even functions, there's 2 different kinds of symmetry. If a function is even, it's going to be symmetric on the y-axis. In other words, this is going to be like a mirror point, so it would be the same over here and here. It does not look like it's exactly alike, even though, because this one's longer. This one right here is longer. So if you folded it, it should have mirror image on the y-axis. If it's an odd function, it'll be symmetric on the x-axis. And you know what? And this is just going to be an either. It doesn't have any symmetry whatsoever. All right. So to determine odd and even, like on that last one, we were just looking at the graph and looking at the symmetry. But on this one, we got to check it somehow. Let's just do it real quick on. So even symmetry. So how we tell, at least the formal way, is to put negative x in for the function. And does it change? If it's the exact same function. And I can tell you just by looking at this, this one is not going to be, but we'll work it out. And then I'll explain to you my reasoning. It says g of x, but I'm already working for this, so I'm going to put negative x. See, now this one, because it's an even power, that thing is still going to be positive x to the 6th. And this right here is an even, an odd power. So that negative x is just going to multiply that. So you got plus 4x. And you see that they're not even. Now, let me write one more little thing, and then I'll explain to you something. If this is true, then we got an odd function. So how do we tell what negative f of x is? Well, all we got to do is just throw a negative sign in front of the original one. And what's going to happen, this is going to be another neither. Oh, wait a second. Yeah, it's going to be another neither, because you're going to have negative x to the sixth plus 4x. So you'll notice that in this case as well, that the original function is not equivalent. So this is neither odd nor even. All right. How can I tell that without having to go all through all that stuff? Well, look, this is an even power, and if it just had the x to the sixth, then it would be an even function. But this power is an x to the first power. So both of the powers, or all of the powers of the function, are going to have to be even for it to be an even function. Likewise, an odd function, all of the powers would have to be odd, like 3, 5, 7, in order for it to be an odd function. But if they're mixed, then it's going to be a neither. So that's a neither. All right. Let's see, how many problems we got in here? I forgot to look. Oh, there we go. So at this rate, we might have a hard time getting through. This one right here is just a plain old quadratic. Anybody got any questions about how to solve this? I don't mind going through it, but like I said, is in for the order of time saving, because we only got, an hour and 15 minutes in this class total. But basically, you subtract the 12, set it equal to 0, and then look for the two factors. I would show you how to do it. You could use the quadratic formula if you wanted to. A is equal to 3, B is equal to -5, and C is equal to -12. So here's something. The graphs on the right show the percentage of jobs in the country's labor force. Something's happened to my other computer here. The internet's said I'm dealing with a really weak thing, but hopefully you can still hear me, because I got the other thing on. All right, so let's just look see what's going on here. The graphs on the right show the percentages of jobs in the country's labor force held by men and women from 1970 to 2010. And the blue is men and red is women. The formula P is equal to 2.2 T plus 35.9 models of percentage of labor force and held by women. So this formula is for the red. All right, so let's just use the graph to do the percentage of held by women in 2000. So what we're just going to do is go up, and it looks to be very close to 50. We could also just multiply it out to make sure. And it said 2000, right? So 2.2 times the square root of 2000. And let's say, we're going to need a calculator for that, because it's going to be an approximation. It's not an exact value. So that, and then we're multiplying it times 2.2. And then we're going to add 35.9. And so we're looking at 134. Someone's not right with that. Hold on. So it looks to be really close to 2000. What did it do? 2000 is the T. So they're saying that this is 49.8. So let's just call it 49. I'm not sure. I must have done something wrong. So let's just go from the chart. Okay, so this is just using from the graph. So let's try that calculation again. I probably did something wrong there. So we got 2000 for T. All right. Times 2.2. Oh, I'm sorry. I'm just being a dope here. It's after 1970. So what we got to do is we got to do two. So it's years after 2000, 1970. So we use the value of T is equal to 40. That's what we're doing. So what's the wording on these things? And it was 35.9. So they that we got like 49.8. So that was pretty close to what we picked. Oh, okay. Well, it was right there. Oh, that's right. It wanted to round it off to the whole percent. That's right. According to the job formula, when will 54% of jobs in the labor force be held by women? All right. So what we got to do is we got to solve for that. So we got to kind of work backwards. So let's see. They want us to have P is equal to 54. And remember the formula was P is equal to 2.2 times the square root of T plus 35.8. So what we're doing is we're given P, all right? We're given P, that equation. And then they want us to know when P is going to be 54. So let's solve that. So we're just going to put the 54 in here. And then just solve what's a T. So we're going to subtract 35.8 because we would isolate the T. So these are going to be gone. And what is 54 minus 35.8? So that's going to be 18.2 All right. So what I'm going to do to isolate the t, I'm going to divide by 2.2 because that's the number in front of that square root. And then that's going to start to isolate the t. So that's going to be about 8.2727. And I'm just going to stop right there. All right. So how do we solve for t? Well, we got to square both sides. Square both sides to get the t out. Forward we go. So the year would be 68 beyond 1970. All right, so what year would that be? All right, so it was 1970 plus, let's just say 68. So it'd be 2038. So 12 years or something like that. All right. If you got any questions, just pipe up. I mean, I'm going fast, but like I said, we only got an hour and 15 minutes, and I want to try to hit what they want to know. Oh. It's 38. All right, what about this one? Anybody got any questions about this one? I mean, basically what you're doing when you do this is you're defined f of x plus 5. You're going to put wherever there's an x on x plus 5. And you're just going to simplify. That's all that means. So again, I'm going to do this the fast way. You can pull it out if you like. Collect like terms. These are all going to be positive, so. So 40 and 25 is 65. Plus 4 is 69. So that's all you can do. All right, so this is one where we're just going to look at this and evaluate. All right, so what this does is t is a function. All right, and x is the input. And it says find and interpret this. So the function, this would be your X, and this is your output. This is your F or your T of X. So for 31, right there. All right, 31 is in this range right here. Then what we're going to do is we're just going to take 31 times 0.1. So 3.1, what that means then is, what we'll see, okay, X is taxable income. So up to $8,500. And since the one that they're talking about is $31, and I assume that that's probably like, I don't know, it may be what it may be. It's not $31, it's 31,000. They don't quite say, but whatever it is, then the tax is going to be 10% as long as it is less than or equal to 8,500. If it had been higher and in between this range, then you got to use this formula, and then if that value there is in this range of 34.5 or above 34.5 all the way up to 83.6, you put it in there. So you just got to remember with a piecewise function, you're just determining which one to use. All right. How about average rate of change? This is just slope. All right, so what you got to do is, in case you're not familiar with it, because it is a bit of a strange problem, because you've got to find the f of x values. In other words, you've got to find the values that are going to go in the numerator. The denominator is going to be 2 minus 1. Let's do f of 2. I'm sorry, f of x of 2, which is 2. So what we're going to do is we're just going to put 2 squared. I'll tell you what, let me make that a little bit better. All right, so this is essentially, let's just call it y2 to simplify things. That's the second point. That's the one that's the counterpart to this one in the numerator. And then f of x1 is equal to 1, or f of 1. This one will be a little bit better easier to figure out. So that's 1 squared is 1 plus 7, so it's 8. So this is the y of y1. And then we're going to use the slope formula, which is y2 minus y1. So it's down here, it's 2 minus 1. And up here, it's 18 minus 8. So all it is just the slope between those 2 points, which is 10. Okay. So I'll just tell you, this is the exact same thing as what we just did. So you're going to find the range rate of change between the ages of 50. So you're using this point and this point. So you calculate the slope. So in the denominator, it'd be 60 minus 50, and the numerator is 22.8 minus 31.8, just to save you some time on that. And that just tells us how much it changes over time. Find the G of 0. So the function. So 0 is going to be, this is years after 1980. So 1980 is year 0. So see, that's 55. And then this is 10, 20, and 30 is what your X value is. Because it says years after 1980. So this is year 0. All right, so year 0 represents 55%. Okay. Identify this information as a point on the graph of the function. So let's see. So right. So we got to calculate this out as what it amounts to. So you got to put 0 in there, and it ends up just being 60. Because if you put 0 in there, it's your y-intercept. So G is a 0 overestimate because 55 was what it was projected to be. So it overestimates by 5%. All right, domain and range, let's see. All right, this is essentially a function. So notice that generally when you have a function, you're going to have no limitation on the range. See, that thing is going all the way that to the left. So that's negative infinity to infinity. The limitation on a function is going to be on the y-axis. So the range starts down here. And what is that value? We're going to figure out what it is. It looks like that's just -1. That's the lowest it goes, is -1. And then it's going up and up and up and up to infinity. What are the zeros? Well, the zeros is where it crosses. So this would be 0, 1, and 2. Oh, they even tell us that. So 2, 3, 4. So the other 0 is 4. The y-intercept is up here. That's 8. They don't say ordered pair. So over what interval is it increasing? It's increasing from right here at the vertex. That's x equal to 1, 2, 3. And then it's going to infinity. Just going to keep on going up forever. And it's decreasing from 8 to 3. And it's constant from negative infinity to 0. Hold on a second, did I do that right? I'm sorry. Hold on a second. It's actually it's the x values, not the y values. So then it's decreasing from here all the way down. So that's 0 as well. The relative minimum is right there. That's 1, 2, 3, -1. All right, what does that say? What is the number at which f? Oh, okay. So they're not asking for the ordered pair. They just want to know at what point does f have that. So it's right there. That's the 3. Oops, let me back up. -1. So that's the x. And oops. At what number does it have the relative minimum? Let me count it again. 1, 2, 3. So I was right. And then the value there is -1. So they don't want it as a point. They want us to break it up. Yeah. Now that's different because it's asking for -1. So 1. So then we're going to go. Oh, oops. -1. So we go up to, and it's 8. Because x is equal to -1 is right here, which goes up to y. Is there more parts? At what x values are what are the x values where x is equal to 3? Or f of x is equal to 3. So that's right here. So that's x is equal to 1. Odd or even, it's neither, because if it were, the problem being is it's not symmetric. If this were going on up and up and up, we would say it's an even function. And then if it were flipped on the other way, it would be odd, but it's a neither. So what do you call this kind of thing here when you got the straight corner? If you got one of these things right here, a quadratic, it's got that's like what we just looked at. It's got the turnaround right there. It's got what they call a vertex at that point. The cubic function is the one where you got several wavy lines, you're doing up and down. So this is the absolute value. That's the only function that does that sharp turnaround like that. It's got more stuff. What else does it want? Oh, and this is what a transformation happens. So it's transformed on a horizontal shift. So that would be 3. So it's got a horizontal shift. It's also got a vertical shift because it's coming down. So that's a vertical shift. And so this will see, let's just figure out which one it is. That's the only 2 that it's doing. So it would be x minus 3. You remember when you translate on the x-axis, it's the opposite. So it's that one. Whoops, I'm sorry, it's this one because then it's down 3. So that's the only one that could hit. And then the domain and range, well, the range for a function is always going to be infinity to infinity. So this is there's only two of those that have that choice. So it's this one because the range comes down to, oh, backwards, backwards, backwards. So it's this one here. Negative infinity, infinity is the domain. Anytime you deal with a function, there's no limit on the range, in the domain, and then the range starts at -3 and goes on down. There's doing more stuff down there. All right, increasing from x is equal to 3 to, where's the infinity sign? Oh, there it is. Yeah, thanks, Nicholas. I didn't see you answer there before. That was a good. What was going? Okay, I did it. And then it's decreasing from negative infinity. So that's here to down there. And that was 3. And just remember, the reason why we're using in parentheses there, because at 3, it's essentially not doing anything. That's a single point that's neutral. It's not increasing or increasing. It's essentially constant at that point. All right, this is an easy one. Okay, the vertex. Remember, it's the opposite. When it's inside like that, it's the opposite of that. So it's -3 and then 5, exact same sign. That gives us the vertex. When it's in this form, that's the easiest thing to be able to figure out is the vertex. So the axis of symmetry is that x coordinate. So the axis of symmetry is x is equal to 1. Okay, that x represents the axis of symmetry. And then the domain is just going to be just like for any function. And in the range, this is going to be the lowest that it gets. We're talking about y. It's going to start at 3. All right, I guess they want to. A second. They want us to graph it, and so I see it's 1, 3, and then hold on. I'm going to do the y-axis real quick. I mean the y-intercept real quick. And what's going to happen is for the y-intercept, you're going to put 0 in here, which is going to give you 1 plus 3. So that's 4. So there we go. That's the graph of it. All right, this is dealing with a picture. All right. All right, so how can we look at the width? The width is So we're gonna have to figure this thing out. Let me do it real quick on here, then I'll write it up there. Let's see about man. I need a real big screen here. This is just not enough room to put all this stuff on here. All right, so we got remember X length times width is the area. So let's just fiddle with the width. The width is equal to X. All right. So the length but they're not asking us to set this up. They're already giving it to us, but you could find that if they had told you how much was being used, and they did tell us, so we could have set that up, but they're giving us a little bit there. So area is equal to X, that's width, times 650 minus 2X. Okay, so that's the quadratic that represents it. So the way we find the values of the length and the width is we just set it equal to 0. So there's no constant term, so we can just solve it by factoring. I'm going to take out a negative 2x, and then that's going to leave us with x minus 325. All right, all I'm doing is factoring it, and then that means 2x, negative 2x is equal to 0. But this is the one we're interested in, because all this is just going to give us is what we call a trivial solution, or it's a solution that can't happen because there's no way the width could be 0. If it's negative or 0, then we're not looking at it. This is the one that's going to give us what we would call the viable solution. And remember, this was W, that's the width. And then the length we find by wait a second. Something wrong here. That's going to come out to 0 when I find it. Make sure that I write some. Oh boy, I should have worked this one out before. I thought I had this one done in my head because we had gone over one just like this. And I don't know, let me come back to that. I'm probably just overthinking it right now because I'm trying to go in a hurry. So we only got about 5 minutes or 10 minutes left. So I apologize for that one. That's kind of why I was hoping y'all would tell me which ones y'all wanted to see. So this is a polynomial. It says determine whether it's a polynomial function. It is. Its degree is the highest degree and 6. So that's easy. Polynomial just means it's got more than one term. All right, so the leading coefficient test, do you remember how that works? The leading coefficient test is 7. So this one right here, because it's positive, what this is going to be is essentially it's a quadratic. So what it does is it falls to the left and rises to the right, sort of like any old parabola. Let's just see what else we got here. We got a couple more. All right, that was the last thing, the long division. I'm just going to set up the long division and then I'll do the other one. And then if you want to take the time, I'll go back and check on that. One with the length and width. But anyway, this one says it wants to do long division. I mean, long division is really not of much use if you know how to use synthetic division, but I'm going to just set it up for you. All right. So this is simply x minus 4. And then inside is 2x to the 4th. And you got to remember, if you're skipping any, you got to put a space holder. So there's no cube, there's no square. I'm sorry, there's no cube, there's a square, there's one of those, and then it doesn't matter about the last one. You can put a 0 there, but it doesn't really add anything. And then it's plus 3, what is it? Minus 3x squared. So just remember, the main thing to show here is you've got to put in a space if you're missing one of those things. So then you just use this to divide into that, put the quotient up there, then back multiply, and then you got to subtract. But let's do the synthetic division real quick since that's the last one. All right, so all right, so it's an x minus 2. So that means then we use a 2 there because you got to use the opposite sign essentially of x minus, because the minus, the way that that number is determined is by having a negative, a double negative there if it's negative. So if it's at x plus 2, then we'd have to use x minus and use minus 2 there. But anyway, then here we just put the coefficients. And you've got to put a 0 if something's missing. See, it's missing on the 4. Because synthetic division is a breeze. There's nothing else missing. Well, let's see if I can fix that a little bit better. And that's why that's more important to learn than this. This one essentially deals with the factors. This one deals with the solutions. So you can do it like this and then revert back to by doing the x minus thing. So bring that down. 3 times 2 is 6. And then we'd add. Because we're doing with that sign change with that number in here, that's why we're adding. 2 times 6 is 12. So it's going to be 8. 2 times 8 is 16. which is 21. 2 times 21 is 42. So this is going to be 40. And then 2 times 40 is 80. So this is 82. So what did it want to know? Three X So there we got it. So see, you can go back to the long division. All right, well, that about brings this time up. Just remember the schedule. By the time we come back in here, have that thing done because it should be open right now. If it's not, let me know immediately. I can easily check, but